So we will directly jump on it. Case CCH slot. Okay, this is not the case here, this is the case here. If not blocked means what? You can start searching where this blocked underscore is written. But I told you some things you should assume. In the first session I told you some things you should assume by their name. If you know the theory, you may assume these things. Okay, what this blocked may say about the medium, and this is the not. If medium is not blocked, then what you can do? You will run these statements. Okay, so these are the statements that actually initiates the transmission. Earlier all the statements were just to check whether we should initiate the transmission or not. Now P is equals to CCH underscore DQ. Okay, since you know all the transmission is done by dequeuing something from the queue. Okay, there is a queue present in the network, or every node has a queue. So we can dequeue that queue. So there is actually in this simulator what they have done, they have not assigned the queue for every node. Okay, they have assigned the queue for whole the network. Okay, why they have done that? That is because it will be good, it will be easy to understand the trace file, and the trace file size is small. Okay, why it is small and why it will be big if we assign queue to every node, I will tell you this, but I don't want to interrupt this discussion what we are doing now. Okay, so CCH underscore is a queue that is assigned for safety message. Okay, the control channel queue, that is where we defined it, I will tell you, we have seen it but I have not discussed it. But for now, understand that P is equals to CCH DQ. So DQ function will do what? Will take the packet out of the CCH queue and put it in the P variable. And what is this variable? Variable is, that is packet type. Okay. So P will be what? P will be a packet that was there in CCH queue, and we have dequeued it using the dequeue function. Okay, is it clear? Okay, now we have called this function without knowing that whether there was something in our queue or not. If there was nothing in our queue, then there is no need to call the dequeue function. So what will happen if there is nothing in our queue? The P value will be 0 or null, we can say. So that is why we are checking. If value of P is not equal to 0, then only we will transmit it. Otherwise, if the value of P, if packet is null, means there is no packet, then we won't transmit. If we try to transmit a packet that is null, it will generate an error. Okay. So if P is not 0, means there is something in P, then what we will do? Blocked is 1. We will do the blocked is equals to 1. Why blocked is equals to 1? Because it will transmit, but all other nodes should not transmit. Okay, or it is, this blocked is for what? If anybody senses the channel during their contention window, then they should sense the channel is not idle. Okay, that is why this blocked is used. Blocked is equals to 1 here, blocked is equals to 0 here, like this. Okay, now this blocked is 1. Now make back of manager, back of window will be started actually here. Actually back of window should be started, and we will call this. What is this actually? This is the receive function. This is the what we will try to do. we will try to get this packet received. What packet? P. And this is the handler value. You should not worry about it. Handler is a thing that actually connects everything at the background. Okay, it works in the background. So you don't need to worry about it because you won't be needing it for your simulation purpose. Okay, so here we are actually transmitting the packet using these commands. You will never have to change these commands. Only what you have to do, you have to change when these commands are called. That thing you might have to change, but not these commands directly. Okay, so what will happen now after, since this class is over now, class means this class, class in the C++ is over now, so it will go back to, not class, sorry, this function is over now, so it will go back to from where it was called. It was called from here. Okay, so now what will happen? CCH timer is scheduled for how much time? CCH time slot minus guard time slot. What is CCH time slot? You can see from here, it is 50 millisecond and here it is 4 millisecond. Okay, so 50 millisecond minus 4 millisecond, that is equal to 46 millisecond. Okay, so CCH timer is scheduled for next 46 millisecond. That is what our theory says. Okay, now this if function is called, so this else if will not be called, obviously, and it is over now. Okay, so what we started from expire, we have completed. We traveled through signal make, we traveled through restart transmission. Okay, so what we have done actually, we tried to transmit a safety packet here, because if you see our TCL file, where it is, let us show you. The TCL file was, if the decide variable is greater than 5, then safety message will be transmitted. If it is less than 5, then non-safety message will be transmitted. Okay, so at this time the value might be anything. Okay, what this value is, that we will discuss. One more thing you should remember, when we are actually starting our data transmission, in the TCL file, it is written as ns at value of start agent 0 send. Okay, so agent 0 send at which time? Value of start. So what is the value of start? You can see at 10th second. At 10th second we are actually starting our data transmission and we are checking at 4th millisecond of the simulation time. So obviously there won't be any data transmission. So what will happen? Some functions will be repeatedly called and will check whether there is some data to be transmitted or not. If it is there, then it will transmit. If it is not there, they will just keep going on. Okay, so we will move towards the 10th second. You can see there will be from beginning you can see that there will be a repetition. Expire, signal make and retransmission. So expire, signal make, retransmission. These variables are being called again and again. And when the SCHI starts, one more function, get next service channel, is called before restart transmission. Okay, so 4 functions are being called when we are in the service channel interval, and 3 functions are being called when we are in the control channel interval, and these intervals will come up at the interval of 50-50 milliseconds each. Okay, so let us move towards the 10th second directly here. 10th second. At 10th second, let us start everything what we have, from where we started earlier, from there only we will start, but somewhat fast. Okay, I am in expire at 10th second. Okay, and since this is 10th second, so what time it will be? It will be either it will be CCHI. Okay, yeah, it should be CCHI. Let us see earlier. Yeah, this one is CCHI. Okay, so let us start again from the expire function, but we will skip what we have already discussed. In expire function, what we will know now, or you can do one thing if you want to simplify the things. You can actually print the value of the current slot and the next slot before this. Okay, before every expire function or inside every expire function, you can print the value of next slot and current slot. That will be much easier. Okay, so we can do that. Where is our expire function? This one. Right. So here what we can do? Printf. So printf is the very important command. The value of current slot is equals to, or don't write equal to, it is %d. In constant.h you can see it is, if it is 0 it is CCH, if it is 1 SCH, if it is 2 it is guard slot. So you can write the current slot is comma current slot under. The same thing you can copy and paste. Just write /n here and paste here. Current slot instead next slot you can write here. Okay, this will simplify our understanding. So let us make this again. This compiled successfully, so there is no syntax error. Okay, so we will run our TCL file again. So let us see the output.txt and directly go on the 10th second. Yeah, here we are there. Okay, so the value of current slot is 1. So what is the current slot? 1 means SCH. Okay, the next slot is guard slot. So why we are jumping directly on 10th second? Because from the 10th second we are starting our data transmission. So not on 10th, we will jump on 10 second and 4 milliseconds. Okay, there is something happening before that. Okay, so we will come here. So start from 10 second only, so that we will understand that not everything is stopped in guard band actually. Inside the node something is happening. Okay, just the data transmission is not there. So in 10 second it is started from here. I am in expire. The current slot is 1, means service channel interval. Next slot is guard interval. So here current slot is service channel interval. What is it? This one. And next slot is guard interval. Okay. So since current slot is service channel interval, we will come here at this point to signal MAC next slot. So signal MAC we will points toward next slot. What is the next slot? Guard slot. Okay. Since it is 0. So go to the signal MAC function here.